For this video, I wanted to go over one of the kinematics equations, and the one I wanted to go over I'm going to call the acceleration equation, or like the average acceleration equation. And you'll notice if we rearrange the variables here, so let me undo that. If we subtract the initial velocity from both sides and then divide both sides by that time, we get something that looks an awful lot like our definition for average acceleration. And so I wanted to show you basically that the kinematics equation is our definition for average acceleration. But I also wanted to show you, if we take a look at the equation as written, it looks a lot like the equation for a line. Where the acceleration plays a role. If you'll notice, this line would have our velocity on the y and our time on the x. So this line would be represented by this equation, and our slope would be the acceleration of the object. And hopefully we can see that in the by the rearranging of the formula. So if the slope is positive, the acceleration is positive. If the slope is negative, the acceleration is negative. If the slope is constant, then our acceleration is uniform. So we can tell by the shape of a velocity time graph the kind of the quantity and the direction of the acceleration. So hopefully this shows you that as the velocity changes, there has to be an acceleration associated with it. And that's the acceleration equation.